All right, so let's actually take this one step further from just talking about the hybridization of the individual atom. Let's talk about a couple of these bonds. I won't go through all of them. I think you can get the idea with just a few, but you can go back and try all of them later. So let's start with thinking about carbon B hydrogen bond. Is this going to be a sigma or a pi bond? Sigma. We know it's sigma because anytime we have a single bond, it's a sigma bond. So carbon B, we just said, is carbon. It's going to be 2sp3. And then hydrogen, what's the atomic orbital we're talking about here? 1s. All right, great. So let's take a look at another one. Let's look again at carbon B. But now let's talk about it bonding to its oxygen there. So again, are we going to be talking about a sigma or a pi bond? A sigma bond. Because again, it's a single bond here. So what we'll say again is carbon 2sp3. And let's take a look at this oxygen that it's bound to. Is this oxygen, what is the hybridization of this oxygen right here? What is it? OK, right, good. It's sp3. It's bound to 2 atoms, plus it has 2 lone pairs. That's a total of 4 things. So it needs to have 3 different hybrid orbitals. So we'll say it's oxygen to sp3. So let's skip to a different carbon now. Let's talk about carbon D, specifically the carbon D oxygen bond. So let's do a clicker question for this one. Let's get into the 90s, if you don't mind. This would be very good to do. It'll make me feel better about you finishing your problem sets tonight. So if you talk about the symmetry and the hybrid or atomic orbitals that contribute, we're talking about the CD oxygen bond. So go ahead and look at your notes to see what that bond is. We already identified the hybridization of carbon D, so we really just need to think about the oxygen here. All right, let's take 10 more seconds. OK, I'll take that, 84%. That's not bad. So again, we're looking at a sigma bond here. It looks like the one people got it confused with was talking about oxygen sp2 versus sp3. Remember, you just need to look at what it is actually bound to. So for carbon D, the oxygen is bound to 2 atoms plus 2 lone pairs, so it's going to be sp3 hybridized. So we'll call this a sigma bond where we have carbon 2sp. Now it's sp2 and oxygen to sp3. All right, let's take a look at just one more here. So let's look at the carbon D bond with carbon E. So if we can switch back to the class notes just to see that, though you guys can see it on your notes as well. So in terms of that, we're talking about a double bond now. So we know that we have to have 1 sigma bond and 1 pi bond to completely describe our double bond. So for the sigma bond, again, it's going to be carbon 2sp2. And now we're talking about the other carbon. What is the hybridization of the other carbon? Yep, sp2. So carbon 2sp2. All right, but we're not done there. We also need to talk about the pi bond. So for the pi bond, we'll talk about carbon 2py, and then the second carbon 2py. All right, so I filled in a few more in your notes, so you can maybe cover those up and make sure that you get all of those correct as a good self-test before you finish off any in your problem set. Does anyone have any questions about figuring out hybridization? Yes? I'm sorry, what is that? In this bond here? Oh, OK, that's a good question. So the question was, why is there not hybridization in these p orbitals here? So in order to form a double bond, we need to have a pi bond formed. And a pi bond forms from 2 unhybridized p orbitals. And if you can kind of picture those p orbitals, if our molecules are this way and they're coming up here, we need to have electron density above the bond and below the bond. So if they're hybrid, then they're going to be spread out into that tetrahedral geometry. We want to have them parallel to each other, and they need to be the p bonds. They need to be the p orbitals. Does that make sense? Okay. So anytime we have a double bond, the pi part of the bond is going to be p orbitals. Yes? No, absolutely not. It would be absolutely correct to put 2px and 2px here. You just can't put z because that's the one that's going to be involved in the sigma bond. And the other important thing is if you do put x for one, you have to make sure you put x in the other because they do need to be able to interact with each other. So you can't have one x and one y, but sure, you can have both x or both y.